Now, let's see what the double angle identities, the half angle identities, and triple angle identities are. So, again, everything can be proven by the fundamental law of trigonometry. Okay, we already discussed this before many times. And we do not need to exactly know how we got all of these identities. You can just prove them by using the identities before, and I'll give you an example as well. But we do not need to prove everything. Just know that these will be given to you, or you'll have to memorize them just to make your life a bit easier. But again, all of these can be proven as well. And here's an example: sine 2 alpha. Well, how did it become 2 sine alpha cos alpha? Now, you know that sine alpha plus beta is equal to sine alpha cos beta plus sine beta, sine beta cos alpha. Okay, now if you replace this beta with another alpha, it becomes sine alpha plus alpha, and that becomes sine alpha cos alpha plus sine alpha cos alpha, which is equal to 2 sine alpha cos alpha, and hence you have the proof for this sine 2 alpha. Okay, and you can do the same for this cos 2 alpha as well, right? You can apply the formula for cos alpha plus beta over here, right? Alpha plus beta, cos alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. Now, if you replace this beta with another alpha, you get cos 2 alpha, and hence eventually this becomes cos alpha into cos alpha, which is cos square alpha, and this becomes sine alpha sine alpha, which is also equal to sine square alpha. And again, if you use the property that sine square alpha plus cos square alpha is equal to 1, you can get these as well, right? Because you can replace this sine square alpha with 1 minus cos square alpha, and you can also get this as well, right? If you just replace this cos square alpha with 1 minus sine square alpha, right? And you have proofs for everything. You have proofs for this as well. If you just use the tan alpha plus beta property, you get this, okay? Just as you did with cos and sine. So now you do not need to worry yourselves with how we got these. Everything is proven to you beforehand. And you can use the same properties to get these identities as well, right? So the basic thing is that cos alpha plus cos alpha over 2 is equal to 1 plus cos alpha over 2 whole under root. The only difference between cos alpha over 2 and sine alpha over 2 is this sign over here, right? These are just shortcuts for you to memorize. Okay, so cos alpha over 2 and sine alpha over 2 only have this difference, and tan alpha over 2 is basically just sine alpha over 2 over cos alpha over 2, and that ends up just becoming equal to this. Okay, and yeah, so that's the half angle properties, and these are the triple angle properties that are very rarely ever used, but still you need to know them. So cos 3 alpha, again, you can prove this by the fundamental law and all the identities that we discussed beforehand. It ends up being equal to this. Just memorize them or they'll be given to you. Sine 3 alpha is equal to this. So you can see that the difference between cos 3 alpha and sine alpha is again very minimal, right? Basically, instead of the signs are opposite and the functions are also opposite. So cos cube alpha, 4 cos cube alpha can be written down as minus 4 sine cube alpha, and minus 3 cos alpha will be written down as 3 sine alpha, right? So that's the relation between cos 3 alpha and sine 3 alpha. And tan 3 alpha is, again, if you divide sine 3 alpha by cos 3 alpha, you end up with this. Fairly simple, right? Or you can use the initial identities with the fundamental law. Okay, but here's the thing. Now let's do a question regarding this. Okay, it says that we have to find the value of sine 2 alpha, cos 2 alpha, and tan 2 alpha. Now these are the double angle identities, It says that sine alpha is equal to 12 by 13. Okay, we'll apply the double angle identity to find sine 2 alpha. Now, sine 2 alpha is equal to 2 sine alpha cos alpha. Okay, so sine alpha is equal to 12 over 13. We need to find cos alpha as well. Okay, and since the values are positive, so alpha lies between 0 and pi by 2. Okay, so sine alpha is equal to 12 by 13. So cos alpha is equal to under root 1 minus sine square alpha. And since sine alpha is 12 by 13, sine square alpha is 144 by 169. Basically 12 square over 13 square. And using that, you get the value as 5 by 13. And since alpha is in the first quadrant, this will be positive, as all functions are positive in the first quadrant. Okay. And we already know that sine 2 alpha is equal to 2 sine alpha cos alpha. So you already have sine alpha, we found cos alpha. So eventually sine 2 alpha becomes equal to 120 over 169. Fairly simple. Now cos 2 alpha, that's equal to cos square alpha minus sine square alpha. And we already found out what cos alpha is, and we already know what sine alpha is. So just take the squares of both and subtract them. Simple. You get minus 119 over 169. Simple. Now, tan 2 alpha is just sine 2 alpha over cos 2 alpha. You do not need to use the identity, the double angle identity of tan 2 alpha. Just make your life simple. Divide sine 2 alpha and cos 2 alpha. We already found them out, and so just divide them. So 120 over 169 divided by negative 119 over 169. And that is equal to minus 120 over 119. So yeah, this is tan 2 alpha. Fairly simple, right?